The train function involves a lot of processes, and it's a very long function, so I hope you guys have the patience to bear with me, okay? So first, we'll start with creating an empty list where we'll be holding the average loss from our training, okay? And we want this list to be outside of the function so we can access it later on. So we'll type average loss. We'll set it to an empty list. And now it's time to start our training function. So let's do def train. And inside our function, we'll specify a few parameters. First, it will be the model that we would like to train it with, which is our StorryTeller. Okay, next, it's going to be our train data. After it, we'll specify the epochs. Epochs is one iteration, an epoch is one iteration over the dataset, okay? Next, we'll specify the last parameter, which is word to index, okay? And that's our legend from much earlier on in this video. So the first thing we do inside the training function is check if we have an available GPU connection, okay? And the reason why we train models on GPU is because if you'll try to do this on your own computer, it's gonna take you a very, very long time. It might even take you days, okay? When you're connecting to a GPU engine, you are basically connecting to a very, very powerful computer that can process your data much, much faster. And that's what we're going to do, okay? So we can check for a GPU connection with an if statement. So we'll type if torch.cuda.is available. And if it's available, the device will be equal to torch.device. And inside the round brackets, we'll specify Cuda 0. And if this is the case, we would like to print that our model is training on GPU. So let's type training on GPU, because we would like to know that, okay? And if it's not the case, if we do not have a GPU connection available, we just add an else clause. Okay, and inside this else clause, we define our device as device. Inside the round brackets, we say CPU. And when we do this, we also would like to print a message saying that it's training on CPU. Awesome. Now, because we defined a device, okay, we'll need to send our model to this device. So we'll just type model.to, and inside the round brackets, we'll say device. So it's either gonna send the model to our GPU or to our CPU, okay? And we'll need to do this with our features and targets as well. And now it's time to account for the epochs. And as I mentioned before, an epoch is a full iteration over all the values in the dataset. So we can simply do this with a for loop. We'll type for I in range epochs. And the first command we'll pass is model.train, because this is where the official training of our model begins. Then we'll add a few variables which will help us with the training process, okay? So the first one would be steps, and this will be equal to 0 because the first time we have 0 steps. The next parameter would be print every, so let's say 100. So every 100 steps, we're going to see a message printed, okay? And that's the purpose of these two. And the last variable inside our train function would be the running loss, okay? So let's type running loss, and it's equals to 0 as well. And now we can start iterating over our database. We can do this with a for loop. So for feature target in train data. And the first thing we'll do is to convert our features into tensors, okay? So we can simply do this with feature tensor, let's call it, okay? And we'll type torch.tensor, okay? And inside the round brackets, we're gonna specify our feature in a list, very important, don't forget it. And we'll also specify the data type, okay, D type, which is torch long in our case. And then we would like to send this tensor into the device, right? As we done with the model. So we'll type feature tensor dot to device. And we'll actually need to assign it to feature tensor as well. I'm glad I remembered this. So let's just copy this, paste it, equals. Good, we replaced it. Next step is setting the gradients to 0. And we can do this with a very simple command, which is model.0 grad. And then we can pass our feature tensor into the model. And we'll do this with log probs equal to model, and inside the round brackets we specify the feature tensor. And now we'll need to convert our targets into tensors as well. And we'll just simply copy these two lines. I'm gonna actually paste them right after. And everywhere where you see feature, okay, we just type target. Cool. And now we can tackle the loss. Okay, so we'll type loss equals criterion, which we didn't define yet, but we'll pass two parameters onto it. We'll pass log probs, which is the features we ran through the model, okay? And we'll also pass our target tensor. And now it's time for some backpropagation, which we can do with loss.backwards. And then we're going to make a step with our optimizer with optimizer.step. And then we're going to add our current loss to the running loss. Okay, so we'll type running loss, which is what we defined. Oh, it's right over here. That's the running loss that is currently on 0. So we are going to add the current loss item. You'll need to specify item, don't just write loss. And that's pretty much it for the training. We'll just need to account for the printing statement that we would like to see once in every 100 steps, as we defined above. Okay, so we can do this with an if statement. If steps mod print every equals to 0, then we'll set the model to evaluation mode, okay, with model.eval. And next, I would like to append the loss into my average loss list from before. We'll type average loss append running loss divided by print every. And now we can move on with our print statement. So print, and I usually start with the epochs. Oh, the runtime disconnected. Okay, reconnect, buddy. Sorry. Okay, so we'll continue with our print statement and we'll just type epochs. And using a format function, I guess we can call it, we'll pass in two parameters. The first one would be I plus 1. Okay, if you remember, I is the iteration variable we set here. Okay, and the second parameter would be epochs. The other value we would like to print is our training loss, because we would like to know in advance how well our model does. So we can simply do this by typing training loss, and we'll also use a format here, and we'll make it look very neat with the .3f. And dot format will specify our training loss, which is again our running loss divided by print every. And once we're done printing, we'll set the running loss back to 0. So we'll type running loss equals 0. And then we'll send the model back to the training mode, okay? But we'll not do this from inside the if statements, we'll do it outside of it. So just backspace, and we'll type model.train. And in the very end of the function, we would like to return our model. So we'll do backspace again, we'll type return model. And because we typed so much, let's just double check that we got everything right. Actually, I already noticed an issue. We have an indentation problem right over here. Basically, instead of sending the model to the device outside of the if statement, we are sending it to the device inside the else clause, okay? So let's just fix this indentation with Shift Tab. This should bring it back to its original position. Okay, and another thing that I didn't do is I didn't increment the steps. We're still at 0 steps, even though it should grow. So let's type steps plus equals 1. And this should do the work, okay? So let's run the cell, Shift Enter. And now it's time to set our training parameters. So we're going to start with our model. So we'll type model equals, and if you remember, our model is StorryTeller. And the first parameter is vocab size. Then we got embedding, dimension, and lastly, we have batch size. Okay, and this should set up our model. Next, we are going to set our loss, which is the criterion. So we'll type criterion. And I'm going to use, at least for now, the negative log loss. We can do this with nn.nll loss. Okay, so we have a triple L going on here. Keep that in mind. And next, we can set our optimizer. So I'm going to use SGD. You can use Atom, whatever you want. So we'll type optimizer equals optim dot SGD. And inside the round brackets, we'll specify the parameters of our model. So we'll type model.parameters. Okay. And then we'll specify the learning rate with LR. And we'll set it to a small value, but not too small. I've seen much smaller values than this. So we'll do 0.01. Okay, that makes sense to me at this point. And once we got this out of the way, we can continue with setting up our epochs. So let's type epochs equals, and just pick a number. I'm gonna pick 10, but you guys can start with 3 or 4. Your model is not gonna be very accurate, but at least it's not gonna take a century to run, okay? So the last parameter I'm gonna set up is our device. So let's type device equals to 0, because we would like it to be Cuda if possible. Okay, Cuda is the GPU connection. And one last thing I want to do before we move on with the official training is to keep track of the time. We can do this with start_time equals to time.time. And now we can train our model. So let's type model equals, okay, train. And then we'll go over our parameters. So our first parameter is model. Our second parameter is our trained data. The third one is the epochs. Okay, and the last one is the word to index dictionary from earlier on. And in the very end of the cell, we're going to print the start time minus the current time. And I'm gonna do this off camera because it's just super easy. And now we can finally run this cell and find out exactly how many errors I've made along the way. So let's run it with Shift Enter. Okay, error number 1 is a typo. So I have StorryTeller instead of StorryTeller, which we can fix in the cell that we build our network. So let's just go there. Okay, we're here. StorryTeller, no. StorryTeller, let's rerun this. And now we can go back to our training function. Let's rerun this cell again. Another typo error. I got parameters instead of parameters. Okay, but this will be in this cell, so parameters. Perfect. Let's rerun this again. Shift Enter. Oh, it looks very, very promising. But I'm usually waiting until the first print statement before I get too excited. Ah, great. We have a result, so we can actually stop this cell from running because we ain't gonna train on CPU. No, 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 no. We're training on GPU, my friends. And before we switch to GPU, we need to make sure that we have a way of saving the checkpoint, okay? So let me just bring up this code and I'll be back shortly. Oh, hi again. So I've included the code for the rest of the cells inside your starter notebook. So if you're using this file, perfect. If you're not, make sure you have a way of saving your model after it's done training. If you don't do this and your runtime accidentally disconnects after the training, you lost everything. And since now we have a very nice cell that will help us do this, we can finally connect to our GPU and start the official training, okay? So we can simply do this from our runtime. So just click runtime, change runtime type, and here instead of none, you'll need to select GPU and hit save. Once you do this, your kernel will disconnect and you will have to rerun all the cells from scratch, okay? So let's just hit on runtime and run all. So obviously I need to remount my Google Drive. It's gonna take me a minute. Okay, let's go down to our training function. Perfect, so everything runs as planned, and just let your model train. It might take you a few good hours, but in the end of the process, you'll be able to check if your model predicts well, and we're gonna do this together, okay? So see you soon. And once your model done training, it is common to plot a graph of your loss. So because I trained my model yesterday and not just now, in full disclosure, I'm going to load it with the help of the loading function I also included in your starter sheet. Okay, so let's just simply run this cell. And we can see it's the exact same model from before because our inputs are 5 times 5, which is our batch size times the embedding dimension, and the output of our network is equal to the total number of words inside our database, which is exactly what we expected. Perfect. And now we can plot the average loss in the next cell with Shift Enter. Yeah, we can do better than this. That means it's not very accurate, or it's not accurate at all. And now that I've lowered your expectations, I am finally comfortable with proceeding to our predict function, where we're going to find out exactly how messed up of a story our network is telling us. So let's run the next cell with Shift Enter. And this is not going to print anything, we're just defining the function here, we're not calling it. And we'll call it from this cell, and we'll do this with Shift Enter. But here, you will be asked to enter the first 5 words of your new story. In my case, it's going to be another lovely day started as. And this must be 5 words because it must match your batch size. So hopefully, if I'll hit enter right now, at least some of it will make sense. But I don't want to make any promises because this is probably going to be a very illogical story. So let's hit enter and fingers crossed. So let's do it. So our story goes like this. Another lovely day started as inclined willow, interrupt proof false, scuttled herald, waded pots, wildly desk oyster. What the hell did I just read? And this is a really good example to the fact that even if you built your model step by step, by the book, no errors, and everything ran perfectly, and you trained it really well, it still doesn't mean that your model is accurate. So essentially, we are very far from finishing this model. This is just the beginning. We still need to experiment with different types of losses and optimizers and epochs and hidden dimensions and embedding dimensions. There's so many variables that we can adjust, and according to this, we can improve the accuracy of our model. So if you guys want to give it a go, you're more than welcome. I'd be very excited to see what you come up with. So thank you guys so much for watching. In the meanwhile, I'll keep improving this model and keep optimizing it. I'll be switching a bunch of parameters. I'll try it with a different optimizer, with a different loss, and we'll see which results give me a better story. And once I'm done, I will definitely let you guys know, and we'll go through this in much more detail, because this is basically an introduction video. This only shows you how it works, not how it works well, okay? So I hope you're having an amazing day, and definitely let me know if you have any questions. Just post them in the comments below. If you'd like to see more videos like this, subscribe, like, and you know, do the usual stuff YouTubers recommend you to do, and I will see you the next time. Thank you so much. Bye bye.